Alright, here's the first step. Just have a regular test light connected to a 12 volt battery, and we're going to test if there's continuity between this bottom pin and the top pin by putting a test light on the top pin and touching the bottom pin to the other terminal of the battery. Let's see if it lights up. Sure does. So there's continuity between here and here. Now we need to energize the relay by using our power supply and testing the other leg of the circuit, seeing if it clicks. Alright, let's turn on this guy. We'll connect it to top and bottom pin. Well, let's first see the voltage here. So we can go all the way up to 24 volts. Not a problem. Now, what's the best way to set this up? Is it just going to pull the relay down? Let's see if 12 volts will energize it. Yeah, it clicks even at 12. I mean, we can bump it up a little bit. We don't need to go all out here. So the relay clicks. I mean, we could just leave it energized. And now we'll do the same check with our test light, trying not to short out our leads. So now we're checking the top pin and this guy. Huh. It's still those top two that are shorted out. Check that out. So the relay, even though it clicked, it didn't really change the orientation of the switch in there. I'll be damned. We could try bumping it up to 24 volts just for kicks. 24 volts. No test light action. It's kind of hard holding this thing in the camera one shot here, but we're still, wow. So put this guy back here. So even though it clicks, doesn't mean it's good. It's a relay problem. Alright, let's cut this stupid thing open. I want to see what's inside. I know you guys want to see what's inside. Keith, we're going to replace the relay, don't worry. Oh, I see metal. Let's do the other side. Oh boy. We see metal? Yes, we do. Oh, it's all going to be epoxied in there, isn't it? They don't want people going in here. I see some contacts there, don't want to hurt the coil. Oh, here we go. Oh boy. Well, I don't think we did too bad there. Ah, we might have messed up the the windings. Blast. We know it was clicking. However, wonder what actually moves in here. Went a little too far with the saw. Get this plastic thing out of the way. Well, that's the control side. Some kind of metal plate. That contact does not want to move. Why not? It's definitely the one that's supposed to move. Those things are fused together. They're actually melted together, I think. That's ridiculous. Why? Try splitting it. Those things are welded. Did the crankcase heater short out? Is there another problem here? I guess potentially, but those two contacts are completely fused together. So we might have heard something clicking here, but no good. That's intense. Should we try to solder them apart? I don't know. Toast. Alright, so we know what the problem is. Why our fan doesn't kick on? The relay was melted shut in the normally closed position. Why did that happen? Well, my theory is this crankcase heater is drawing too much amperage and it's on all the time by design. Just looking at the wiring diagram, there it is, the crankcase heater. It's permanently wired to L2 through the relay, the red one, to L1, and L1 is powered on all the time. So why the heck is this thing on all the time? Found a video on YouTube that explains the function of this thing. It's actually strapped around the bottom of the compressor. We'll give some credit to Great Furnace Man. Let's listen.
The crankcase heater. What is a crankcase heater? Why is it sometimes put on air conditioners or heat pumps? Well, here's a strap-on type. This one kind of goes together like that with this little clamp on it. And these parts here are in contact with the compressor. I'll show you one on a compressor here in a minute. And they transfer the heat from this small heating element in the crankcase heater to the compressor to warm the compressor. Now let's take a look at one that's installed. It's right there. It's the same type as you're seeing on the bench. It's actually strapped around the compressor towards the bottom. So why is it put where it is? It should be at about the oil level of the compressor, and it's going to warm the oil in the compressor. So why do we care? Does the oil not work well at low temperatures or what? Well, actually, that has nothing to do with it. What we're looking at here is something to keep refrigerant out of the compressor.
That's the key.
Refrigerants go where the coldest temperatures are and they have an affinity for oil. Both of those are in the bottom of this. If this is cold, it's outside, this is a heat pump. They do it for air conditioners too sometimes, but heat pumps is more common. If the compressor gets cold, it's going to draw refrigerant into it. Okay, what's wrong with having refrigerant drawn to the compressor? Now this is in the off cycle, not when it's not running, because it warms up when it's running. When refrigerant is brought into the compressor, and this is on the low side, this is a can side of the compressor, it mixes with the oil. When it mixes with the oil, it dilutes the oil. It's kind of like pouring solvent into motor oil.
All right, so there's the reason of why we need this crankcase heater. So the refrigerant doesn't pool in the compressor apparently. That's why it's on all the time. These things draw up to 200 watts, so you're basically wasting energy just by having a heat pump outside. I didn't know that. Interesting. Anyways, I want to replace this heater, and then when we get the new one, measure the resistance of it, because apparently it's shorted out or drawing too much current and melting our relay. Also, I think a better thing to do, instead of wiring it back to this relay, so this basically acted as a fuse. I don't know for how long it's been blown. And basically it's like not having a heater at all. We can just wire the heater directly to L1 and L2, and it'll be on all the time, even when the thing is running. And that way we won't have this problem again. It won't cook the relay, it won't burn the circuit board out. I don't know. Is that a good thing to try? Because otherwise, I mean, might as well buy 2 relays, just have a spare. But it seems like the design of this isn't the best, because the heater's on all the time and the circuit board is just flowing current all the time, and obviously you see the consequences. Granted, I think it worked fine for, oh, when was the house built? Like 2007? So 10 years. New one might work fine for 10 years. We could put it back together the way it was. But this is kind of digging deeper and finding the real root cause of the problem. Why do we have no heat? Yeah, because the heater burned the circuit board out, melted the relay, blah, 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 blah. So yeah, that's the diagnosis. We're going to get some parts. This heater is readily available. So is the relay. We're not going to replace the board. That would be silly. Pay $600 for something they don't need. And we'll come back with the repair. Alright, one-stop shopping on eBay. I'm getting 1 Carrier crankcase heater, that strap-on type, and 2 Potter and Brumfeld 5-pin relays, just to have a spare on hand. The 11402 4F, brand new, and that's it. Gotta love eBay. Alright, it's the next night with the Bryant HVAC unit. So I got the board here reinstalled. I still want to run this thing even though we don't have the relay anymore, and our crankcase heater is shorted out. We can measure the resistance. The fan, the black wire right here, I connected straight to line 1. So whenever I turn the breaker on, that fan will spin, and we'll be able to heat our house, and it'll just stay spinning no matter what this thing does. I opened up the side panel and here's what we found. I was looking for the crankcase heater. I don't see that strap-on type that we saw in the YouTube video. However, we see a lot of, what is this, rodent damage. I mean, this insulation is supposed to keep the compressor warm, but apparently there's a mouse nest in here. This is ridiculous. I think they like the warmth of the compressor. Oh man. clean some of this crap out. I want to see where these red wires go to our crankcase heater. So we have, let's see here, this guy. Let's see what that's all about. This is just a big plug. Or not. Okay. So our red wire here, get some of this crap out of the wiring. Oh, that's a problem. What the heck? Is that thing just shorted out? I think it was just rubbing on the metal. That's it. That's our problem. It's ridiculous. We might be able to fix this thing. Still need a relay. However, we might not need a crankcase heater. So let's see how this thing is wired up. So there's two red wires for some reason. We'll have to see where they go. And then our plug for the compressor. Yeah, I'm going to leave that alone. We're going to have to fix this. Here is our twisty tie, so we can just strip some of the wires and tie this thing on there. Guys, I'm really, truly amazed here. So where do these red wires go? Well, there's one and there's two. And they both go up here. So two red wires we're looking for. Obviously there's one of them. And the second one is tied to, well, I guess the feed, right? Since that's line 2, I believe, with the yellow. Yep, so we have a constant line 2 feed to here, and then line 1 from the other side, and they're 180 degrees out of phase, and they go boom, 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 boom. So that right there explains the burned out trace on the circuit board and the fried relay. Just because this thing is vibrating, I don't think it has to do with the mouse nest. Finally, this guy fell off, and then this guy shorted out on the actual body of the compressor. How unfortunate. The good thing to do here is get these things out of the way and maybe tie them up with the wire bundle so they have no chance of shorting out again. Let's clean this crap up here. Wow, crazy. We could even hook that up to line 1 as well to have the crankcase heater operational. Now, here's my question. I guess these red wires go to these black wires, and then, oh crap, black wires come down here, and one of them is broken. I don't know if it was chewed off. The other one is almost broken. So we could still measure the resistance of the heater, so it basically lives inside of the compressor, I guess. It's supposed to be sealed up. Yep, there's like a silicone plug down there. So we have some wiring repairs to do on this thing, actually. So we're doing the wiring repair down at the bottom. Already got one soldered and shrink wrapped. Do number 2. These wires take a little time to heat up, especially with the cold weather. But the butane soldering iron can't be beat for field work. See, the wires have to heat up to melting temperature to accept the solder. I dipped them in a little bit of flux. They were kind of corroded and dirty down here. There's a lot of moisture, especially if it's been raining all freaking summer long. Go underneath here. Not too bad. Should be good enough for our application here. Do a little Keith tug test and then put our shrink wrap right on there. The good stuff. Make sure it covers the entire repair. Oh man, love it. So basically this turns out to be a $25 repair, right? All we need is that relay, and we're going to measure the resistance of this heater after I get all the wires put back together. I cleaned up and re-crimped this guy, so we're going to tie these to the wire bundle instead of letting them sit up in this cap area. But otherwise, we should be in good shape. So there's the repair. 2 wires soldered and shrink wrapped. Let's tie these guys out of the way, and we'll do our resistance check from this wire to the red wire right here. So the resistance from the red to the red is 1.8 kiloohms. Does that make sense? So let's say, for the sake of argument, we have 120 watts. That's half an amp at 240 volts. Got it? Now, keep in mind, when this thing heats up, should the resistance drop or lower? It should go up. So I'm not exactly sure, you know, the specs of this thing. It was 180 watts for the one that goes around. Maybe this one's more efficient, so it draws less amperage. But in any case, if we have what was it, half an amp at 240 volts, V equals IR, so R should be at least 500 ohms, so half a kilo ohm, it's 1.8. I mean, it's steady, so there is continuity at least. It's not burned out, it's not shorted. It's not going to cook the relay again, so I figure once we have this thing powered up, we could hook it up and measure the current with our amp clamp. I'm actually curious to try this. We can measure amps in AC. So let's give that a shot too. Let me go turn the breaker on. All right, let's turn these guys on. Indoor unit, outdoor unit. Didn't trip anything, so didn't short anything out yet. Let's go upstairs. Camera lens is fogging up. Kitty! Meow. Alright, we're back online. It's 60 degrees. Let's make sure we don't have any trouble code set right now. Wait for this camera lens to defog. Service, fan coil status, it's off, yep. Run fault history. No faults in the fan coil. Sorry about the foggy lens, it's a little cold outside. Heat pump, no faults. Alright, let's get out of here. And heat. Bump it up to 66. See what happens. Alright, well, we got fan action. Fan is constantly hooked up to line 1 and line 2, and so is the heater. I'm just curious to measure amperage. So AC, zero that out. Let's go on one of the red wires. 0.2 amps. Guess I'm fine with that. And the fan, yellow or black. Let's try the yellow. About 0.6 amps. Not too bad. Double check this heater. 0.2. Alright, well, now is the compressor working? I think that just the fan is working. Did we forget to plug something in? I don't think we did. The compressor should kick on. Everything looks good here. Well, I guess we can measure the amp draw out of the compressor. If it's not on, it usually sounds louder than this. Alright, AC, zero that out. I don't think the compressor is drawing anything right now. I mean, you should throw a fault code if the compressor is not kicking on. It should flash something there on the trouble codes. It's steady. And the compressor is controlled by, oh, let's see, one of these big switches, I think. You can look at our wiring diagram over here. Compressor. Black. Oh, there it goes. Sweet. Oh, we got a blinky. Well, at least it kicked on. Let's measure the amp draw on that. There you go, 8.5 amps on the compressor. I mean, it should work. What is LED doing? It's not really flashing a code, is it? Let's see here. Short flashes indicate the first digit, followed by long flashes indicating a second digit. Here we go. On, no flashes, standby. Pause, low stage. To pause, high stage. So it should be low stage. It's kind of constant blinking, isn't it? Well, it's doing its thing.